Myself, Dr. Pravita Kumar, Professor in Department of Chemistry, Shri Aurobindo College from University of Delhi. Learners, today we will discuss a very important topic, green solvents for sustainable future. If we talk about the sustainability improves the quality of our life and it prevents our ecosystem, also prevents the natural resources for the future generation. But if we talk about the chemical sustainability means reduce the use of hazardous or toxic chemicals, reuse, recycle, using the renewable feedstocks, designing the chemicals, using of safer chemicals are the term related to the sustainability of in the chemistry, and these are used in the chemical reactions. Solvents are important for industrial and domestic application. In each application, whether we are using any industrial product or we are using any domestic product from our cleaning product to dishwasher, everywhere we use the solvents. So, solvents are the important for industrial and domestic applications. The impact of solvent losses and emissions derive efforts to minimize them or avoid them completely, and this gives rise to the idea of green solvents. Everyday use of the solvent such as washing dishes and cleaning floors, exposure to solvent is one of the most common health and environmental risks at the workplace. On your screen you can see different types of that solvents, and these are the commercial solvents which we have used in the industrial and other applications. Common solvent used in industry are acetone, petroleum spirits, dichloromethane, hexane, toluene, methanol, white spring, xylene, etc. Industries where the solvent are used, paint manufacturing industries where the consumption of solvent is very high. So, paint manufacturing industries, printing, plastic and rubber industries, construction chemicals. Even in the construction we have used a lot of chemicals, lot of solvents. Footwear, textile and food stuffs also. Dry cleaning also used in dry cleaning also chemicals. Woodworking. In construction industry, solvent act as carrier for surface coating such as paint, varnishes and adhesives. The main effect of these solvents are irritation of skin, in our eyes, and also affect the lungs. Sometimes at the workplace or the place where the solvents are using, we can feel headache, acute headache, nausea, dizziness and other many symptoms. So, the use of green solvents can reduce these health risks as well as environmental risks. Here, solvents are an important type of chemical product with a multi-million market, and learners, solvents are close to commodities. Why these solvents are close to commodities? Because they are highly in demand. They are highly demanded chemicals, and these solvents are made up of fossil resources and can be toxic and very flammable. Solvent These conventional solvents can be obtained by the gas processing plants and oil refinery plants, and the major chemical building block of the petrochemical industries are syngas, ethylene, propylene, butanes, toluene, benzene, xylene, and other products from the crude oil and the natural gas. So, there are different types of solvent we can obtain from the gas processing plants and the oil refinery plants. Basically, from the petrochemical and gas processing plants, we can obtain that solvents, that's conventional solvents. So, these solvents or chemicals which are obtained from the gas processing plants or oil refining plant can be transferred into functional solvents through the process of oxidation, hydrogenation, dehydrogenation, dimerization and esterification. Aromatic solvents which obtained from the petrochemical like benzene, toluene and xylene, collectively called BTX. It is an oil refinery term and which is produced by catalytic reforming of crude oil. So, these are the three important conventional solvents which is obtained by petrochemical, that are benzene, toluene and xylene, and these are collectively called BTX. Now, how can we define the solvent? Solvent is a substance, usually liquid. So, solvents are the liquid chemical substance which is used to dissolve other materials, other chemicals or other reagents without chemically change them. So, when we use the solvent to dissolve any chemicals and reagents, there is no chemical change takes place between the chemicals which we dissolve in the solvents. Now, solvents can be liquid, but they can be gas, solid or supercritical fluids. Supercritical fluids are the material which can be either liquid or gas above the critical temperature and critical pressure where they can exist or coexist as a liquid and gas. So, supercritical fluids are also wonderful green solvents. Solvents comes from the Latin word, that is solvo. Solvo means loosen or unite. On the basis of chemical composition, that solvents can be classified into inorganic solvents and organic solvents. Inorganic solvents can be aqueous solvents. Organic solvents can be hydrogenated solvents, hydrocarbon solvents, oxygenated solvents, and the solvents can be polar protic solvent, non-polar aprotic solvents. So, on the basis of that chemical compositions, we can classify the solvents. These are the example of, on your screen you can see here, these are the example of some organic solvent used in synthesis and industrial process. Learners, solvent market is projected to reach 30 billion USD in 2025 from the USD 21.8 billion in 2020. Why? Because there is a huge demand for solvent from home care and personal care. You can see on your screen there is a pie chart where we can see in the painting and coating industry, you can see in the graph 46% of solvent required, and similarly agrochemical products or agrochemical industries we require 2%. Similarly other industries, you can see the percentage of solvents required during the industrial process. Similarly, printing and ink, we have to require around 6% of that solvents. And China is the largest producer and consumer of the solvents. Learners, chemical solvents constitute around 80% of total volumes of chemicals processes. Use of organic solvent as a traditional synthesis has been and continued to be practiced. An argument is made from the environmental perspective for a long overdue switch to alternate reaction media, and that alternate reaction media is a green solvent. So these conventional solvents are highly volatile organic solvents or organic compounds which are obtained from the petroleum resources and bearing several health problems and environmental risk. Prolonged exposure of solvents may lead to chronic disease. These are on your screen, you can see these are the organic solvents and these are the product of toluene, the substituent of toluenes. So, if any person have maximum exposure to toluene, we call this toluene abuse, and there can be possibility of cerebellar damage. So, we can say how the conventional solvent are a great risk for our health, especially at the workplace where the people use these conventional organic solvents. So, some of the short term effects of these conventional used organic solvents are used in laboratory. In laboratory we have to prepare the synthesis, and in pharmaceutical industry, biomedical processes also. These are having a very toxic effects, having corrosive effects. They are flammable in nature, very reactive in nature, incompatible, and can cause environmental damage. So, the replacement of these toxic solvents with one that show superior environmental health and safety properties, biodegradability or reduced ozone depletion potential. So, the green solvent is a long term solution for minimizing the environmental depletion. Now, green solvents are alternative solvents of that conventional solvents. They are also called sustainable solvents also. Why they we call green solvents is sustainable solvents? Because they are environment friendly. If we talk about the cost, they are very affordable. They are having very less energy consumption. They are very stable. For health purpose, they are very safe. They are renewable. They are convenient accessibility of these alternative solvents, these green solvents. One wonderful properties of these green solvents are they are biodegradable. They are non-toxic or less toxic, atom economical, and they all green solvent follow the aims of green chemistry, process efficiency, and if we use in any synthesis, we have to get a very good yield. So, these solvents, green solvents, when we use in chemistry, when we use in any chemical reaction, we call the reaction is sustainable reaction or sustainable synthesis, because we can explain, I have explained a lot of properties the green solvents have. And these are the 12 principles of green chemistry. Green chemistry is efficiently use of raw materials, eliminating waste, avoiding the use of toxic and hazardous solvents and reagents, and the use of organic solvent in sustainable synthesis are biosolvents, because the biosolvents are environmental friendly solvent, and these are the solvents which are obtained from the processing of agricultural crops or non-food products. So on your screen you can see these green solvents, these biosolvents which we can obtain from the agricultural crops, and they are because we have to obtain these solvents from the crops, so they are biodegradable, and these are the wonderful solvent and alternate to petrochemical solvents. Now, types of green solvents. First type is, and very important type of solvents, is bio-based solvent, that is also called biosolvents. So these solvents are obtained from the sugar sector, wood sector, oleochemistry sector, which is derived from the renewable resources, agricultural crops, and these all the sectors having, they are rich in carbohydrates like cereals, sugar sector, woods, and that agricultural crops all are having carbohydrates, example corn, wheat and beets. So from that carbohydrates a lot of transformation, microbial activity takes place that convert into sugar, and from that sugar we can get the bio-based solvents. So bio-based solvents are amazing and wonderful solvents for the industrial application, for the laboratory synthesis and for the chemical processes. Now one example I would like to discuss you here, ethyl lactate. So on your screen you can see the ethyl lactate is an amazing and very important green solvent, and it is derived from the processing of corn, and it is because the corn contain carbohydrates, and that ethyl lactate is a ester of lactic acid. So the biomass everybody knows, we get agricultural crops, woods, also we call this biomass. So that biomass contain lactic acid and ethanol. That lactic acid and ethanol, after the processing, different processing, we get a ethyl lactate. So that ethyl lactate used in coating industry, having a wonderful high solvent power, excellent cleaning power, and the conventional solvent, that is the chlorinated solvent, can be replaced by that ethyl acetate. So ethyl acetate are the very good green solvent, can be replaced by the wonderful chlorinated solvent, that organic chlorinated conventional solvents. Another very important green solvent is water. Water is universal green solvents. Why the water is universal green solvents? Because water can dissolve maximum compound in it, and maceration, they can act as a supercritical fluid condition. They can act also with enzymes. When the enzyme used with water, it enhances the activity of enzymes. Water can be hydrotrophs or can act as a surfactants. So water is a wonderful green solvent, and this is called, water is also called universal solvents. Another green solvents can be used, that is liquefied gases. Example, the carbon dioxide and butane, liquid ionic liquids and eutectic solvents. These are also act as a green solvents. Eutectic solvents are the plant based primary metabolites, example organic acid, sugars, alcohols, and both are liquid state of ionic mixture. So ionic liquids and eutectic solvents are liquid state of ionic mixture. So we can say the biomass which we have to obtain from the agriculture waste, non-food waste, we can convert that biomass into biosolvent. Biosolvent is a green solvent, and that biosolvent is used in organic synthesis. You can be used in pharmaceutical industries, and the biomass, because the biomass contain starch and lignocellulose. Also from the animal fats we can obtain bio-derived solvents like alkanes, aromatic ionic liquids, furans, ester liquids, polymers all have a unique physiochemical properties. And use of a solvent agent in manufacturing pharmaceuticals, cosmetics, chemicals, energy, food and industries. So, all these biosolvents which we can obtain from the biomass can be used in the cosmetics which we used on our daily basis. We can change that conventional solvent with these bio-based solvent or biosolvents. So, the sustainable solvents derived from the biomass having minimum health risk, minimum environmental sustainable health risk. Example, alcohol and esters, hexanes, they are considered as a low environmental risk solvents. On your screen you can see the sustainable solvents which is derived from the biomass and having the minimum environmental sustainable health risk. You can screen on your screen sunflower or sunflower oil or animal fats. We can get acids, fatty acids, terpenes we can obtain from the plants, and also you can see the sugar corn, the corn having sucrose and starch, also the lignocellulose, wood having also that lignocellulose, and that contain into the sugars, and sugar after fermentation, because there is a long process and there are several reactions takes place during the conversion of that biomass into biosolvents. So, we can convert that sugar into different types of solvents like ether, alcohols, acids, esters, furans and aromatic phenols also, alkanes also. So, these are the bio based solvents which are having a minimum health risk. They are very sustainable. If we talk about the environmental risk, they are having zero environmental risk. They are non-toxic or comparable very less toxic regarding the conventional solvents. So, here bio-based ethanol. Bio-based ethanol is currently the most produced of all biosolvents. So, the biosolvent is also, bioethanol is also called biofuel, right. So, the biofuel which is a bioethanol is currently the most produced of all biosolvents, and that biosolvent which is used as a biofuel produced through the biological transformation, especially many enzymatic reactions, many biological transform takes place, and during the transformation the sugar, especially that biomass contain in corn, sugar canes. So, they have a sugar, they have a carbohydrates, that carbohydrates converted into sugars, and that sugars change into bioethanol and other many very usable byproducts. So, learn out world first cellulosic ethanol on the large scale production plant was commissioned in 2013 by Beta Renewables. So, that industry is generating, preparing or synthesizing biofuels from the sugar canes and corn. So, these especially products, these are the products of agricultural waste such as rice, straw and giant cane, and ethanol is the most common use we can use, and in fact industries is using that bioethanol as a biofuel and also used as solvent in consumer product such as in perfumes and also food coloring, flavoring, alcoholic drinks and in certain medicine and natural products. So, in this part we had discussed about the solvents. What are the solvents and why it is important to change that conventional solvent to the green solvents, and we had discussed how we can obtain the green solvents. We have learned there the green solvents can be obtained from the biomass. The biomass, which is especially agricultural waste, from the agricultural waste we can obtain the green solvents. Green solvents are having a very good properties if we comparable with the conventional solvents. They are biodegradable, they are non-toxic, they are very less cost effective, energy efficiently, and they are having a other many more properties which I have explained in this part. Thank you.